This is me Arzu here and I welcome you to my channel Mr. Teeth, where your dental concept get dissected. So this is our part 5 video of the dental cement series, and in this video we will be discussing with the glass ionomer cement. Okay, so glass ionomer cement is one of the most important chapter in the dentistry. Okay, I am telling dentistry, okay, not just dental material but dentistry. So glass ionomer cement is a very important chapter. So I have prepared a proper note, okay, including all those important points that are to be known, okay, that are to be known by every dental student. Okay, so you guys should just listen this video properly, just enjoy this lecture, and after that you can read the notes. Okay, so I will be keeping all those notes in my telegram channel, so from that telegram channel you can get those notes. Okay, so you can revise from those notes, you don't have to prepare your own notes. Okay, so just listen to me in this video and get your concept dissected in this glass ionomer cement. Okay, so without delaying much, let's start today's video. So glass ionomer cement, okay, so glass ionomer cement, so it is adhesive tooth colored anti-karyogenic restorative material. Okay, so it means that, okay, so glass ionomer cement is adhesive. Okay, so it adheres to the tooth structure and it is a anti-karyogenic, okay, anti-karyogenic restorative material, means it releases the fluoride, okay, and it is of the tooth colored. Similarly in 1972, okay, Wilson and Kent, they named, okay, aluminosilicate polyacrylic acid. So in 1972, okay, Wilson and Kent discovered the glass ionomer cement and named aluminosilicate polyacrylic acid, okay, at that time. Okay, so it is called ASPA, okay, ASPA. So in 1972, Wilson and Kent named aluminosilicate polyacrylic acid ASPA, okay, and discovered the glass ionomer cement. And then glass ionomer cement, okay, so how it is named is that, okay, so glass means powder is a type of a glass. Okay, so the powder, okay, that is present in this cement is a type of a glass particle. Similarly the ionomer means there is a presence of the ionic bond. Okay, so as I have told, there is an adhesion between the glass ionomer cement and the tooth structure. Okay, so that the bond that is present between the tooth structure and the cement is an ionic bond. Okay, similarly, okay, so it is also called as the biomimetic material. Okay, so biomimetic material means it has similar mechanical properties as that of the dentine. Okay, so similar to the dentine, okay, it have mechanical properties, so it is called biomimetic material. So this, okay, so they can ask sometime you in viva. Okay, so what biomimetic material, okay, so what is a which is a biomimetic material, then you should tell glass ionomer cement is a biomimetic material. Okay, because it have similar mechanical properties with that of the dentine. And the other names, okay, so synonyms of the glass ionomer cement is polyalkylate, okay, cement, and another is ASPA, that is aluminosilicate polyacrylic acid. Okay, so they okay, so these two are the synonyms of the glass ionomer cement. Okay, similarly the available, okay, so availability of the glass ionomer cement. Okay, so how they are available, so they are available in powder and liquid form. Okay, one another in a capsule form. So in a capsule form, as they are pre-proportioned and they are kept in a capsule, separating powder and the liquid, that is in between them there is a septum, okay, that separates the powder and liquid. Okay, and after that a light cure system. Okay, so light cure system, okay, so there is a mix of both the powder and liquid, and when we apply the light over that mix, okay, so it gets set. Okay, so light cure system is there, and powder distilled water settable type is also present there. Okay, so these are the four availability. Okay, so the types of availability of the glass ionomer cement. Okay, so just you remember this. After that, in application section, okay, so there are many applications in the dentistry, okay, of glass ionomer cement. Glass ionomer cement are used extremely. Okay, we use extremely glass ionomer cement in everything, okay, in our dentistry. So first of all, the glass ionomer cement, okay, it is used as an anterior aesthetic restorative material, just like in a cavity 3 and cavity 5. Okay, so as we read in a GB Black classification of the cavity preparation, in that section, okay, we have studied that class 3. Okay, class 3 is a cavity. Okay, it is a type of a tooth preparation, cavity preparation, that is present on the proximal wall. Okay, proximal wall of the anterior teeth, okay, without touching the incisal edge. So that is a class 3, and class 5 means and class 4 means touching the incisal edge. Okay, similarly the class 5 is present in the gingival third of all the teeth. Okay, so in those cavity we use as a restorative material. Similarly it is also used as a luting agent. Okay, so we can use it as a luting agent, attaching the prosthesis to the tooth structure, luting agent. Okay, similarly liners and bases. Okay, after that for core build up. Okay, so when there is a more loss of the tooth structure, so for building the core, okay, we can use the glass ionomer cement. Similarly there we can also use it as a for the pit and fissure sealant. okay. And after that, atraumatic restorative treatment, okay. So this is very important to understand, that atraumatic restorative treatment, okay. So in atraumatic restorative treatment we use the glass ionomer cement. So they can ask you in a viva, okay. This is a distinguishing feature, okay, distinguishing application of the glass ionomer cement. So what is ART? It means that minimally invasive dental procedure that is designed to prevent and treat the dental caries or the tooth decay, especially in the community with a limited access. So where there is a limited access, the community where there is a limited access, in those places, okay, we do minimally invasive dental procedure, okay. So we use just a hand instrument, okay, and just remove that dental caries, okay. We just remove the dental caries or the tooth decay, and after that we fill the glass ionomer cement in that, okay. So hand instruments are used for the excavating the tooth decay, and they are restored by the GIC, okay. So we should know about this ART, automatic restorative treatment, okay. So they both are important. After that, the contraindication, okay. So contraindication in which we shouldn't have to use glass ionomer cement is the cavity number 2 and cavity number 6, okay. So cavity number 2, okay, so cavity number 2 and in cavity number 6, they, as in those cavity, okay, we just require the larger mechanical, okay, stronger restorative material. We need a stronger mechanical properties, okay, so that as they lack fracture toughness, okay, and susceptible to the wear, okay. So in, as it is not strong more mechanically, we can't use in those cavities. So just remember, in cavity number 2 and cavity number 6, they are contraindicated, okay, we can't use, okay. But their modifications, okay, but their modifications we can use in those 2 and 6, but the conventional form of GIC can't be used there, okay. Now in the classification section, so we have three sections of classification, okay, three bases of classification. So according to the Wilson and McLean in 1988, so type 1, type 2 and type 3. So type 1 is a luting and a bonding agent, type 2 is a restorative cement, and type 3 is a liners and the bases. So these are the three types of the GIC, okay. After that, based on the proposed application, so how we use the glass ionomer cement, okay. So on the basis of those application, we have classified the GIC on the 9 types, okay. And this is very important, okay. So when I faced the viva of this dental material, at that time too, my examiner asked me the same question, okay. So tell me the classification of GIC, okay, on the basis of their application. So at that time I have told all those, okay. So you guys should remember all those points, okay. So type 1 is a luting cement, type 2 is a restorative material, type 3 is a liners and the bases, type 4 is a fissure sealant, type 5 is orthodontic cement, type 6 is a core build up material, type 7 is a caries stabilization and a preventive material, type 8 is anterior ART, okay, material, and type 9 is a posterior ART material for geriatric and pediatric patient, okay. So just remember all those, okay. Okay, just first three are similar with that of the first classification, okay. And additional is there a fissure sealant, okay, as I have told in my application section, okay. They are also used as a pit and fissure sealant, so remember from that, okay. So they are used as a fissure sealant, okay, remember like that, okay. Similarly in type 5, just remember orthodontic, okay. So something should also become, orthodontic, as I have told, GIC is widely used in a dentistry, so it should be used in all the specialities of the dentistry. So by remaining that statement that I have told recently, so you can remember this orthodontic cement. What I mean to say that, okay, just remember, okay, we have, as a glass ionomer cement, we are studying in the conservative, okay. So just remember, okay, it is used in all over the dentistry. So just from that point we can just remember this orthodontic cement, okay. So remember, okay, as it is widely used, so we can use it in orthodontic, but we can't use other cement in orthodontic. So like that you can remember this, and also you can remember by your own way, okay. But how I remember is this way, okay. So orthodontic cement, and after that core build up material, so it is also came from the application, okay. So core build up, as I have written here, so type 6 is a core build up. And one thing I want to say that, okay, in type 4 you can't say the core build up material, okay, and in type 6 you can't say the fissure sealant, okay, that will be wrong. So always say type 4 fissure sealant and type 6 core build up material. So what the type is and what the cement present in that type, you should tell thoroughly, okay. You can't mix anything. And type 6 core build up material, and in type 7, okay, as it is anti-carcinogenic, so those type of cement, caries stabilization and preventive material, okay, comes under this group. And in type 8 and type 9, okay, so type 8 anterior ART material and posterior ART material, geriatric and pediatric patients. So remember like that, okay. And also you can make your own way to remember this classification, but you should remember all these types of the glass ionomer cement. After that, okay, the newer classification, that is the third classification, is that, okay, so traditional glass ionomer, metal modified and resin modified. So they both are the modified form of the conventional GIC, and they are the traditional form. So traditional glass ionomer cement are the luting cement, restorative, liner and bases, similar as that of this Wilson and MacLean classification. And in metal modified glass ionomer cement, we have further two types. One is a miracle mix. Okay, miracle mix, in this what we used to do is, in miracle mix, spherical silver amalgam alloy. Okay, silver alloy we use, okay, in the GIC, so it is called miracle mix. Okay, and in cement mix, okay, cement mix or cement cement is another type of this metal modified glass ionomer. After that, I will discuss all those in upcoming time, okay, in this video itself. Okay, so resin modified glass ionomer cement or the hybrid ionomer, it is a another. So in this we add the resin in the GIC, in this we add the metal in GIC. So we completed the classification section, and also I have added this commercial names. Okay, so it is not so important, but also you can see once. Okay, so aquakim or aquasim, what you pronounce. Okay, similarly Fuji, they are the luting GIC. Okay, so they are luting GIC. Similarly Ketak bond means bases and the liners GIC. Kimfield and Fuji second is a restoration GIC, and Vitra bond is a light cure GIC. Okay, so you can just remember those, or also you can't remember those, then it is okay. After that, in composition section, okay, so this is very important. Okay, very important. So we have powder and liquid. Okay, so in powder, the mainly powder what we call is that it is contain the acid soluble calcium fluoroaluminosilicate glass. Okay, so there is a presence of the, so remember this full name. Okay, acid soluble. Okay, acid soluble calcium fluoroaluminosilicate glass. Okay, so it is a quite big name, but you should remember this calcium fluoroaluminosilicate glass, acid soluble calcium fluoroaluminosilicate glass. As I am repeating it, you should remember this. Okay, after that, okay, so the measure, there are 6 constituent. Okay, measure we can say that, okay, measure there are 6 constituents. So one is, first is silica, and another is aluminum fluoride, calcium fluoride, sodium fluoride, and aluminum phosphate. Okay, so when you will see this composition, okay, of the GIC, it is bit similar with that of the silicate cement. Okay, if you have watched my silicate cement, okay, video, in that video I have discussed with the composition of the silicate cement. So in that video, okay, I have discussed the proper composition of the powder. So there is a little bit similarity in the silicate cement powder composition and in the glass ionomer powder composition. Okay, as both contain the glass particles. Okay, so there is a presence of silica, aluminum fluoride, calcium fluoride there. Okay, and also there is a presence of cryolite. Okay, if you have not watched that video, please do watch the silicate cement video. Okay, so you can relate both the videos. Okay, relating the things, okay, will make things easy. Okay, why the people think that I will study just this much and I will be okay for my exam. Okay, so that is properly wrong. Okay, you should link all those videos. Okay, all those chapters, sorry. Okay, so when you study this gentle cement, don't just omit the silicate cement as they don't ask in exam. Okay, just study that too, because it is a first cement. Okay, it was the first cement to be discovered and to be used. Okay, so you should study everything and relate all those things. Okay, and it will make more easier. Okay, you guys will feel better after studying all those topics. Okay, after that, okay, in silica, it is 41.9%, aluminum 28.6%, aluminum fluoride 1.6%, calcium fluoride 15.7%, sodium fluoride 9.3%, aluminum phosphate 3.8%, and fluoride portion. Okay, so the fluoride portion is here, aluminum fluoride, calcium fluoride, sodium fluoride. So they act as a ceramic flux here. Okay, so they will be acting as a ceramic flux. After that, lanthanum, strontium, barium, or the zinc oxide, they add the radio opacity to the glass ionomer cement. Okay, after that, okay, in the liquid section, okay, so we have a major 3 component. One is polyacrylic acid, is in the form of copolymer. Okay, so is in the form of copolymer with the itaconic acid, malic acid, and tricarboxylic acid. Okay, so this is very important. Okay, so polyacrylic acid is present there. Okay, polyacrylic acid is present there, which is in the form of copolymer with the itaconic acid, malic acid, and the tricarboxylic acid. Okay, so tricarboxylic acid, so you can remember this by team. Okay, so you can remember this it by team. Okay, so tricarboxylic acid, malic acid, and itaconic acid, polyacrylic acid in the form of copolymer. Okay, after that tartaric acid is also present there. Okay, and it improves the handling characteristics and working time is also increased and decrease the setting time. Okay, so you just remember these 3 points. Okay, what does the tartaric acid do in this liquid form? They can ask you in the exam. So it improves the handling characteristics, increase the working time, decrease the setting time. And as I have missed here, okay, so this polyacrylic acid that is in the form of copolymer, it increases the reactivity of the liquid, decreases the viscosity and decrease the tendency of the gelation. Okay, and also there is a presence of the water. Okay, so it act as a medium. Okay, so water is also very important in the liquid of the GIC. So it act as a medium of the reaction and hydrates the reaction product. Okay, after that, okay, so there is also, I have written the composition of the water settable cement. Composition of the water settable cement. So what we do in water settable cement is that, okay, we use the freeze dried polyacrylic copolymer. Okay, so there is a freeze dried. Okay, so this polyacrylic acid copolymer that is present here in this conventional GIC. So what we do in water settable is the freeze dried. Okay, so simply there is a freeze dried polyacrylic copolymer, okay, added to the glass ionomer powder. And in liquid, okay, so in liquid there is water with a tartaric acid or itself water. Okay, so when we mix the powder and the liquid, okay, so when we mix the powder and the liquid, there is a polyacrylic acid powder. Okay, so this polyacrylic copolymer is in the form of the powder. Okay, as it is freeze dried. Okay, so it takes the form of the powder and we add it in the glass ionomer powder. And after mixing those powder and the liquid, okay, so goes into the solution forming the liquid acid. So there is a formation of the liquid acid and the chemical reaction takes place, okay, as like the conventional powder and the liquid system. Okay, so just remember, and this is it. Okay, so the advantage of water settable cement is that, okay, so it set faster. Okay, so I will tell once again. Okay, so in water settable cement, what we do is, okay, we take the freeze dried polyacrylic copolymer that we were using as a liquid form in the conventional GIC, but here we take the freeze dried polyacrylic copolymer added to the glass ionomer powder. So it is a powder form. Okay, freeze dried polyacrylic copolymer will become powder, so it is the powder form. And in the liquid we take water or the water with the tartaric acid. So mixing this powder and this liquid, okay, will form the liquid acid. Liquid acid is formed. Okay, and a similar chemical reaction is taken place as that is being taken in the conventional GIC. So they set faster. Okay, so that is the advantage. So we take the water settable cement, they set faster, they do not require much time, so we take water settable cement. Okay, so now we will discuss about the manufacture. Okay, manufacturing process of this glass ionomer powder. So what we do is components are sintered at the 1100 degrees Celsius to 1500 degrees Celsius. Okay, so we just mix the ingredients of the powder and we sinter, and glass is ground to the particle size of this. Okay, so it is a bit similar with that of the previous zinc phosphate or zinc oxide usinal or silicate cement. Okay, as I have told there, okay, we just mix the particle of the ingredients of the powder and we just sinter it, okay, at the 1400 degrees Celsius, I think, okay, in previous videos, but here we just sinter at the 1100 to 1500 degrees Celsius, and the particles are grinded to the size of 15 to 50 micrometer. Okay, after that, in the setting reaction, okay, so this is one of the most important thing of this chapter, setting reaction. Okay, so you just remember for the luting, okay, so that is a type 1 GIC, and there is a 4 to 5 minute of setting time, and in restorative GIC there is a 7 minute of the setting time. And so I have prepared the proper flow chart of the setting reaction. So you should, after watching this video, okay, so I guarantee you, after watching this video, you shouldn't have to watch any other video in GIC. Okay, or you should read the book. Okay, after watching this video, you will be proper in this video if you catch all the and every point that I've included in this note. Okay, so just remember all those points. Okay, you will be bona fide in this chapter. So as I have written, the mixture of the powder to the liquid. Okay, so when we mix the powder to the liquid, okay, so what happens, there is liquid, okay, that contains the polyacrylic acid. So acid attacks the glass particle, okay, similar with that of the previous cements. Okay, attacks the glass particle and release of the calcium, aluminum, sodium and the fluoride. Just you should have to remember is that the ions, okay, that are present, that are released in this setting reaction. Okay, so there is calcium, aluminum, sodium and fluoride. Okay, so in the aqueous medium, so these ions are released. Okay, and okay, facts. Okay, so you can remember this by a facts. Okay, So I have prepared this mnemonic. So fluoride, A for aluminium, C for calcium, S for sodium, okay, in the aqueous medium. And after that, okay, so there is a calcium cross linking happens there. Okay, so what means this is, okay, calcium ions are chelated, okay, by the carboxyl side groups of the polyacrylic acid. Okay, so the polyacrylic acid contains the carboxyl side group, and those carboxyl side groups, okay, chelates the calcium ion, okay, of the GIC. And also this carboxyl group, okay, chelates the calcium ions of the tooth structure, okay, that will form the formation of the amorphous polymer gel. Okay, amorphous polymer gel is formed there. Okay, after this chelation of this calcium ion, okay, so cross linking happens there. Okay, so what I mean to say that, okay, so polyacrylic acid that have the carboxyl group, okay, so it chelates the calcium ions too, and also chelates the calcium of the tooth structure too. So there is a calcium cross linking present. After that, after the calcium cross linking, there is a formation of the amorphous polymer gel. Okay, and again after there is a aluminum cross linking. So when there is a cross linking of the aluminum ions, okay, it makes the matrix more stronger, and it takes place 24 to 72 hours later. So it is more slowly reacting aluminum ions. Okay, so more slowly reacting aluminum ion produce more highly cross-linked matrix that is now more mechanically strong. So when there becomes aluminum cross-linking, okay, so the matrix become more stronger, okay, in comparison to the matrix that was only containing the calcium cross-linking. Okay, after that the sodium and the fluoride ions, okay, so sodium and fluoride ions are also present there. The sodium and fluoride ions do not take part in the cross linking, and sodium replaces the hydrogen from the carboxylic group, and rest combine with the fluorine forming the sodium fluoride. Okay, so this is telling that sodium and fluoride, okay, so sodium usually replace the hydrogen ion, okay, and they do not take part in a cross linking, and they replace the hydrogen ion from the carboxylic group, and also sometimes sodium and fluoride they again combine and form the sodium fluoride. Okay, after that there is a gelation. So gelation means what? That, okay, so there is a gelation of the polyacrylic acid, so polyacid by the metal ions. So metal ions gelates the polyacid. What happens is there that unreacted glass particle is sheathed by the silica gel formed due to the leaching of the ions. Okay, so in gelation what happens is that, okay, so the ions that are leached from the glass particles, okay, so they react with the, okay, so they react with the, okay, so those ions, okay, so those leaching of ions, okay, when it comes in a matrix, okay, so they form a sheath like structure. Okay, so silica sheath like a gel like structure. Okay, so gel like structure is formed around the glass particle. Okay, it is a distinguishing of the glass ionomer cement. It was not present in the previous zinc phosphate and zinc oxide usinal, but in the silicate cement there was a presence of the sheath, okay, there also. So you can just relate from that too. So here what happens, the leached ions, okay, so they form a gel like structure, okay, and that is sheathing around the unreacted glass particle. So that process is called gelation. So unreacted glass particle is sheathed by the silica gel formed due to the leaching of the ions. Okay, after that hydration and maturation happens there, and water acts as a medium in this hydration and maturation process, and later it is slowly hydrating the matrix, adding the strength to the cement. Okay, so hydration and maturation is simple to understand. So what happens is that water act as a medium earlierly, but after when all those cross linkings and gelation completed, after that it just hydrates the matrix. Okay, so it is hydrating substance to the matrix, and it which adds the strength to the cement. Okay, so you can just remember this flow chart, okay, and just copy this flow chart in your exam. Okay, you will get the full marks in your theory exams. Also you can learn many things from this flow chart for your viva exam. And I have drawn the set structure of the glass ionomer cement. So here there is a matrix of hydrated calcium and aluminum cross-linked polyacrylic acid. So calcium cross-linking, aluminum cross-linking forms the matrix. Similarly, silica sheath gel is present there. Okay, so silica sheath gel is present around the unreacted powder particle. So this is a structure of the set mass. After that, okay, so the set mass, okay, so that is a set okay, so those GIC that is set just recently. Okay, so in those recently set GIC, if there is exposure of the cement, okay, before the proper set leads to the loss of the cations and the anions that forms the matrix, as they can be dissolved. Okay, it is very important to protect the cement surface by varnish application. So so the cement, the GIC that is recently set, okay, so it is very sensitive okay, so that it should be protected with the varnish application. So we apply the varnish, okay, as we are applying in the zinc oxide usual zinc phosphate, okay, we used to apply the varnish over there, similar as that here, okay. So the proper set, before the proper set, okay, the loss of cations and anion can take place, so we used to apply the varnish over it. After that I have written about the water, okay. So this is also a very important viva question, okay. So there are two types of water in the GIC. So one is loosely bounded water and another is a tightly bounded water, okay. And loosely bounded water is that water that is easily removed by the dehydration. So when we do the dehydration process, it is easily removed. Similarly, in the tightly bound water, it can't be removed and remains as an important part of the set matrix. So it is tightly bounded to the matrix itself and it can't be removed even after the dehydration. Okay, so now we will discuss with the properties of the glass ionomer cement. So in the properties section, first we will discuss with the mechanical properties. So compressive strength of the conventional GIC is the 85 MPa, okay. Similarly, the for the luting GIC and for the restorative GIC it is 150 MPa, okay. So just remember the data of the GIC as the everything, okay. Everything in this chapter is very important, so just remember those data too, okay. So 85 MPa and 150 MPa. In tensile strength, luting GIC 6.2 MPa, restorative GIC it is 6.6 MPa, okay. The hardness is 49 K Knoop hardness number, that is lower than the composite, and fracture toughness, okay, so it is also lower than the composite, okay. And elastic modulus, it is half of the zinc phosphate, and wear resistant, it is more susceptible to the toothbrush abrasion, okay. So just what is written here is that, okay, so it is a little bit mechanically compromised cement, okay. Conventional GIC is mechanically little compromised cement, as the restorative have 150 MPa, okay, which is good, okay. So compressive strength is good of this cement, okay, but this elastic modulus, okay, so to resist the masticatory force, it is half of that of the zinc phosphate, okay. So it is one of the disadvantages of this cement. Similarly, wear resistance can be there, more susceptible to the toothbrush abrasion, okay. So you just remember those data, okay. So these data are also so important. So one thing I want to tell that, so how you can remember this, okay. So I have how I have remembered is that 6.2 to 6.4 6.6. So when you add 4, okay, 0.4 here, so 6.2 becomes 6.6, okay. So what is this 4 means? GIC cement, okay. Just you remember this glass ionomer cement, okay, but again you add the cement, okay. So GIC, so there is 4 letter, so 6.2 to 6.6, so plus 4 means that is a tensile strength, okay. So now film thickness, in film thickness it is of 25 micrometer. In solubility and disintegration, it is initially highly soluble but completely setting take place in 24 hours, and after that, okay, luting type have 1.25 percentage by weight the solubility, okay. Similarly, restorative type would have 0.4 percentage by weight, okay. After that, in adhesion section, okay, so it bonds to both enamel and dentin, and better it bonds with the enamel than the dentin. So this is a conceptual, okay. So why it bonds more better in enamel than the dentin is because, okay, in the enamel there is a presence of the larger mineral component, okay. So there is a presence of larger amount of the calcium in comparison to the dentin, so there can be a lot more amount of the cross linking, okay, in the enamel, but not so in the dentin, so that there is a better adhesion. Similarly, due to the reaction between the carboxylic group of the polyacid and the calcium of the hydroxyapatite, okay. So I have discussed with this in the setting reaction, okay. So same thing is told here, okay. So carboxylic group of polyacid, okay, reacts with those calcium of the hydroxyapatite and also with the GIC, well, GIC's calcium, okay. So CO minus of this polyacrylic acid, calcium is present in between, and here is the enamel, okay. So in this way bonding is there, okay, between the GIC and the enamel, okay. After that, in aesthetic, okay, so it is inferior to the silicate and the composite. So silicate is a best aesthetic cement, okay, but it have high amount of high amount of pulp irritating property, so that we don't use that, but it is very aesthetically good cement. So GIC is inferior to the silicate and inferior to the composite. Similarly, it lacks translucency and have the rough surface and texture. Luting cement is more opaque than the restorative cement, okay. So luting GIC is more opaque than the restorative GIC. After that, in biological properties, so the pulpal response is mild in GIC, and pulpal reaction, okay. So I have prepared a comparison, okay. So here zinc phosphate is greater than GIC and GIC is greater than zinc oxide usual. So there is a extremely mild pulpal reaction in the zinc oxide usinal cement. Similarly, in GIC itself, okay, so type 1 luting have a more pulpal reaction than the type 2, that is restorative GIC. After that, in pulpal reaction, pulpal protection, if a remaining dentinal thickness is less than 0.5 mm, then thin layer of calcium hydroxide is placed as a liner, okay. So if RDT is 0.5 mm and less than 0.5 mm, in such a case, we should use glass ionomer cement as a liner, and it releases the fluoride, so it is anti-carcinogenic, okay. And the one important thing, okay, which I missed in my viva, okay, so during my viva of this dental material, the examiner asked me the fluoride discharging. At that time I didn't knew this, okay, so I added here. So fluoride discharging means it is a process by which a restorative material, okay, specifically GIC, absorbs the fluoride from the solution with a high fluoride concentration. So it is very easy, okay. So we may have I may have heard about this but didn't know properly, okay. So I couldn't tell in the viva, but I have written properly here, okay. So fluoride discharging means the process by which GIC especially, or also can be other substances, okay, what they used to do is they absorb the fluoride from the solution that is the having the high fluoride concentration, okay. So that is a fluoride discharging. After that I have written the advantage and the disadvantage, so you can go through those, okay. So addition to the tooth, good marginal seal, anti-carcinogenic, biocompatibility, minimal cavity, preparation required, okay. So how much there is a caries, okay, similar to the composite, okay. So we do not require the proper cavity forms, okay, for the GIC. And in disadvantage, low fracture resistance, low wear resistance, water sensitive during the setting phase, and less aesthetic compared to the composite, okay. So this is a disadvantage of the GIC. After that, in manipulation section, okay, so there are manipulation section I will be discussing in the 5 different points, okay. So in manipulation, our first point is a surface preparation, okay. So when there is a tooth decay or the tooth caries is present there, so what we do is we excavate the caries of we excavate that portion of the tooth and we just apply the GIC, okay. So after excavating that portion of the tooth, okay, what we do is, okay, we just rub with a cotton plate and the pumice slurry, okay, or also we can do itching, okay. So this is better than that reacting with the pumice slurry. So itching with a 10% polyacrylic acid and 37% phosphoric acid, okay. So when we do itching, okay, so there is increasing in the surface energy, okay. So that will help in a proper bonding of the GIC. And 10 to 20 second of the conditioning is done there, okay. And after that 20 second is rinsing, okay. So after when we apply this agent, okay, over that cut surface of the tooth, and we just rinse it with the water surface, okay. So after this itching, there will be presence of the frosty appearance will be present there on the tooth surface, okay. And the main purpose of this surface preparation is to remove the smear layer, okay. So to remove the smear layer, enhance the wettability of the tooth surface, and similarly the pre-activates the calcium and the phosphate ions in the dentin, okay. So just you can say those purposes of itching or the surface preparation, okay. So remove the smear layer, okay. So smear layer is that layer, okay, that is that is formed, okay, during the cavity preparation. So that those smear layer, okay, is removed by this itching, okay. So what the smear layer is that, okay. So when we prepare the cavity, okay, then the debris, okay, so the cutting debris that are formed due to the cutting of the tooth structure, okay, get collected on the surface, okay. So those structure forms the smear like layer above the cut surface, so that is called the smear layer, okay. So it is particularly formed by the cutting debris, okay. After that, it enhances the wettability of the tooth surface. So it enhances the wettability of the tooth surface, pre-activates the ions of the dentin. Now in the preparation of the material, how we prepare the material for the manipulation is that powder to liquid ratio for the restorative it is 3:1, and for the luting it is 1.8:1. Similarly, the armamentarium that is required for the GIC is paper pad and the agate spatula or the plastic spatula. So you can remember these two, okay. Many of us know we use the plastic spatula, but what is the another name of the plastic spatula, that is agate spatula, we are unaware of that, okay. So just remember this, agate spatula means the plastic spatula itself. And powder and liquid should be dispensed just before the mixing, and powder is divided into the two half, okay. So as we divided into 6 to 8 increments in the zinc phosphate, here we divide in a two half, okay, and should be rapidly incorporated into the liquid. After that, in which motion we should manipulate the GIC is the sweeping and the folding motion, okay, in order to preserve the structure of the set, okay, set mass, okay. So in order to preserve the structure of those matrix, okay, you used to do motion of sweeping and the folding motion. Similarly, the mixing time is 45 to 60 seconds, okay. After that, okay, after mixing there will be a glossy appearance of the GIC, okay. So this glossy appearance have its own significance. It means that, okay, there is a presence of the residual polyacrylic acid, okay. Residual polyacid is present there, and which can aid in the proper bonding of the GIC to the tooth structure. So that is the significance of the glossy appearance of the GIC. After that, how we place the GIC in the mouth is, okay, so restorative cement mixer is applied by the plastic instrument, okay. So plastic instrument, comes in the preclinical conservative or conservative instrument set, okay. So there is a plastic instrument present there, okay. So we carry it by the plastic instrument and we fill in the tooth cavities, okay. So and while filling we should do overfilling, okay. So we should overfill the cavity, and after the placement, surface should be covered with a plastic or a okay, so plastic matrix, okay. So we should cover the placement of that GIC by the plastic matrix, okay. And why we used to place this plastic matrix over the restoration is that, okay, so it protects the cement, okay. So as I have discussed earlier, so recently manipulated cement have a very poor properties, okay. So when it comes in contact with the oral fluid, the properties of the GIC would degrade. So that we should cover with the plastic matrix, so it protects the cement and it provides the maximum contour, okay. So this is important, ensure the adequate adaptation, okay. So it protects the cement, provide the maximum contour and ensure the adequate adaptation of the restoration. After that, in finishing section, hand instrument are preferred over the rotary to avoid the ditching, okay. So when we use the rotary instrument, there may have ditching, okay. So now another point is further finishing is done after the 24 hours, okay. So just the thing you should remember is here the hand instrument, okay. So hand instrument we use for the finishing, not rotary instrument. After that, the protection of the restoration, okay. So how we protect the restoration is that, as I have discussed earlierly, okay. So we can use the varnish, okay. Similarly, resin bonding agent can be used, and cocoa butter or petroleum jelly can be used, okay. So these things are applied over it, okay. So varnish is applied over it for the protecting the restoration, and the purpose is to protect the cement from the drying or desiccating, okay. Now if unprotected, so if it is unprotected, okay, then chalky or the creased surface is formed, and this chalky and creased surface is also formed if there is a low powder to liquid ratio and improper manipulation, okay. So you should remember this, so very important. So what I have told here is that, okay, so if there will be low powder to liquid ratio during the manipulation, as I have discussed in this paper, as I have told here, powder to liquid ratio for the restorative cement is 3:1 and for eluting is 1.8:1, and if the powder to liquid ratio is low, okay, comparing to those data, then in such a case there will be formation of the chalky or the creased surface, okay. So especially in the restorative GIC, it occurs, okay. So if there will be low powder to liquid ratio, it means that low 3:1 powder to liquid ratio. If it is low than 3:1 ratio, then there is a chalky or the creased surface, and improper manipulation also can cause this, okay. So we have completed with the manipulation portion. Now we will discuss with the modifications of the GIC, and this is also a very important topic, okay. So water settable GIC, as I have discussed earlier, so same thing is present in this water settable GIC. What we use is freezed poly acids, okay. So we use freezed, okay. So freezed polyacrylic copolymer is used there, okay. So just if you have confusion in this again, so just watch it, water settable GIC once again, okay. After that, in resin modified GIC, okay, also called light cured GIC, dual cured GIC, or hybrid ionomers, okay. Hybrid ionomers, light cured GIC or dual cured GIC is present in this resin modified GIC. After that, in composition section, okay, so it contains the ion leachable glass, that is silica, and the alumina is present there. Photo initiator or the chemical initiator is present there, okay, as it is initiated by the light, okay, or the chemical. Or again, there is also a presence of the polymerizable resin is also present there, and hema is present there, okay. So these four are the constituent of the powder of the resin modified GIC. And in the liquid section, so it contains the polyacrylic acid, water, and the methacrylate monomer. So it is similar with that of the conventional GIC. The addition is there of methacrylate monomer, okay. The setting reaction is by the polymerization, and the acid base reaction takes place. So polymerization, it takes place by any sort of stimuli like that of light, okay. So there is a presence of photo initiator, chemical initiator, so those cause the polymerization start, okay. So polymerization is there and acid base reaction takes place in the setting reaction. Now it is supplied as in the form of the chemical cure form, dual cure form or tri-cure form. So chemical cure form, there is a acid base reaction only, and in the dual cure form there is acid base reaction along with the light cure of the resin. So this light cure resin would cause the polymerization, and tri-cure acid base reaction, light and the chemical cure of the resin. So these are the three forms, okay, of the resin modified GIC. After that, in the properties of the resin modified GIC, okay, so the strength or the compressive strength is lower than that of the conventional GIC, and which is 105 MPa. Tensile is 20 MPa, which is greater, okay, and greater fracture toughness is present there, okay. Similarly, in a hardness, okay, it is 40 KHN, okay, and there was 49 KHN, I think, okay. So you can just see once again. So hardness, there is a 40 KHN, which is little bit closer to the conventional GIC, okay. So let me confirm once. Okay, so the properties, okay, so there was 49 KHN, okay, so I am correct. So 49 KHN is in conventional GIC, and here is a 40 KHN. So adhesion, it is similar with that of the GIC, and also the macro mechanical retention is also present here. Similarly, in the micro leakage, okay, so this is an important thing of this, okay, resin modified GIC. So there is a greater amount of the micro leakage, and it is caused due to the polymerization, shrinkage and wetting of the tooth. So these are the two factors that are causing the micro leakage of the resin modified GIC. Similarly, in the anti-carcinogenicity, it is equivalent to the GIC, and it is mild pulpal response is present there, and it is more aesthetic than the conventional GIC. After that, the usage of the GIC is there is a permanent cementation of the PFM crowns, bridges, and the metal inlays, onlays, and the crowns, and as the adhesive liners as high strength bases and provisional restoration, okay. So we can use it as a permanent cementation, okay. So for permanent cementation we can use this resin modified GIC, okay, or also we can use it as a adhesive liners, okay. Again, also we can use it as a high strength basis and provisional restoration. So now we will study about the compomer, okay. So actually compomer is a resin is a type of the resin modified GIC, okay. So we are learning it here, okay. So this resin modified GIC, okay, so this resin modified GIC have the two form, okay. So one, the proper resin modified GIC form, and another is this compomer, okay. So what compomer is actually is, it is a polyacid modified composite or the compomer, okay. So it is also called as a polyacid modified composite, okay. Polyacid modified composite is another name of the compomer, okay. After that, I have written here fluoride releasing, okay. So it is also release the fluoride as like the conventional GIC, and also there is a more durability as like that of the composite, okay. So as the composite have the proper durability, so the durability of the composite and fluoride releasing as that of the conventional GIC. So these both the features are present in the compomer, and the components of the compomer is that, so it contains the silicate glass particle and the sodium fluoride in the powder, and similarly in the liquid it contains the polyacid modified monomer without any water, okay. So there is a presence of the polyacid modified monomers is present there without any water, okay. So they are the constituent of the compomer, and the photoactivator that is present in the compomer is the 2-hydroxyl methacrylate, and also or other butane carboxylic acid can also be used as a photoactivator. So 2-hydroxyl methacrylate, okay, can be used as a photoactivator, or the butane carboxylic acid can also be used as a photoactivator here. Similarly, in the uses of the compomer, so it is used as the restoration in the periodontic. So for the in a periodontic we can use it as a restoration in non-stress bearing areas, okay, for bases and the luting class 5 lesions. So the uses are a bit similar, okay. So as they are the modifications of the GIC, so as where we use the conventional GIC, so in those places we use those modifications, okay, but they have a little more specificity. Just like that, I have told here, it is used in a restorations of the periodontic, okay. So in the periodontic it is widely used. Similarly, restoration in the non-stress bearing areas and class 5 lesions. So in class 5 lesions there is a less stress, okay, as it is present in the gingival third. So in those places we use the compomer. After that, it is supplied as a light cured single paste or the powder liquid system or the two paste auto mix system, okay. So two paste, that is auto mixed system, is also available. After that, in bonding mechanism, it requires the dentin bonding agent prior to the placement of it, because it doesn't contain the water which could make them self-adhesive, okay. So they are not self-adhesive to the tooth structure, okay. So prior to the application of this compomer, what we do is the dentin bonding agent, okay, is used prior to its placement for the bonding mechanism. And another point what I have written is here, water reabsorption is also high here. Okay, that is a 3.5 percentage by weight is present. Okay, so water uptake by this compomer is high. Okay, that is 3.5 percentage by the weight. Okay, so water reabsorption means the solubility. Okay, how it is more soluble, little bit similar with that of the solubility. And after that I have written release the less fluid than the conventional GIC. Okay, so it releases the less fluid than that of the conventional GIC. Okay, after that our last paper of today's video is, okay, so the metal modified GIC. So in 1977, okay, it was discovered. Okay, so the scientists think that if we add the metal in the conventional GIC, it would have improved strength and fracture toughness. So they added the metal modified GIC, but it was not like that. Okay, okay, so the goal, so the motto of this mixing was not fulfilled by this metal modified GIC. Okay, so I will discuss with that in this mechanical property. So in 1977, for the improving in strength and the fracture toughness, there was the invention of the metal modified GIC, and modified by the addition of the metal particles, and metal acts as a filler here. Okay, so there are two types of metal modified GIC, that is a silver alloy admix or miracle mix, or another is a cement. Okay, so silver alloy admix means it is made by mixing spherical amalgam powder to the glass ionomer powder. Okay, so silver alloy. Okay, so spherical amalgam, so silver and the mercury. Okay, silver and the mercury is amalgam. Okay, so that is a spherical amalgam powder is added in the glass ionomer powder. So you should remember this: spherical amalgam powder, silver alloy admix. Okay, so these are very important term. So in miracle mix, this is a famous terminology for this metal modified GIC. Okay, so miracle mix, so they can ask you in a viva what is present in the miracle mix. What we add in the GIC is that silver alloy admix is used. Okay, or spherical amalgam powder. Okay, we use in the this conventional miracle mix. Okay, metal modified GIC. After that, in the cement, okay, so the bonding of the silver particles to the GI particle and sintering of a mixture of the two powders at the high temperature. Okay, so in a cement, okay, so there is a bonding of the silver particle to the GI particle. Okay, and sintering of the mixture of the two powders at a high temperature. So at high temperature we do sintering, and there is a bonding of the silver particles, okay, to the GI particles, means glass ionomer particles and the silver particle. There is a better bonding. Okay, so cement and this is bit similar. Okay, this is bit similar. And the uses of the metal modified GIC is that, so we use the metal modified GIC in the posterior restorations and for the core build up. And the properties of this metal modified GIC is the mechanical properties. Okay, so in mechanical properties all the strength are similar to that of the conventional GIC. So it was just like a, and no appreciable advantage of using the metal modified GIC over the conventional GIC. Okay, so there was no appreciable advantage as we added the metal, okay, in this conventional GIC. So we thought that there would increase the strength. Okay, but there was not so. All the strength of this metal modified GIC were similar with that of the conventional GIC. So in this anti-corrosionic property, okay, so it is a less fluid releasing because of the metal coating. And in aesthetic, okay, so it is gray in color because of the metallic phase within them and not suitable for the anterior restoration. Okay, so we have completed all the topics of this glass ionomer cement. Okay, I have tried to explain all those important points of this glass ionomer cement to you all, guys. Okay, so for making those videos and for making those notes, okay, I used to especially for making those notes, I used to see different sources. Okay, I used to see books, I used to see different kinds of books, different kinds of notes. Okay, so after looking all those notes and the book, I used to prepare those notes. So there is a lot more effort in doing all those things. So I request you all to, okay, so just like, subscribe and share with your batchmates. Okay, I will catch you in the next video. Till then, stay happy, stay healthy. Tata, bye bye, thank you.